So the question is it possible to merge multiple of these bodies together?
Like an object orientation that you inherited from.
Yeah, you want an inheritance mechanism, right? So you want some defaults and then you want to add stuff to the defaults. And no, that's not possible. Not the way it's designed today. And it was designed that way for the purpose of avoiding the problem of inheritance specifically, because inheritance can get you into a lot of trouble. And it complicates, it introduces a hierarchy into this, whereas this is completely flat. And the hierarchy, I think, gets you into more trouble than it solves. There's clearly the freedom to create as many of these templates as you like, so you could compose them in any way that you want with different names, making it clear what has been composed. But by not allowing multiple substitutions, if you like, or extendability in this way, you avoid the possibility of accidentally including some bits that you didn't mean to include through inheritance.
Yeah, but in this way you have to copy it all over.
In this way you have to take responsibility for it yourself. Yeah.
Exactly.
Yes, you do.
Also allows you to make mistakes.
Now, in the future we may change that a little bit, because when we come to manage network devices, routing and switching devices, it turns out that routing tables, of course, have many similar kinds of entries in them. So the promises we've been able to configure using this model so far have been quite simple, quite one-dimensional in some sense. In routing, it becomes much more two-dimensional, and it might be necessary to allow multiple bodies to be incorporated in that way. But if that's the case, then there needs to be some strong checking of the things that are being composed together to make sure that it actually makes sense in some way. The more freedom you give, of course, the more freedom you have to make mistakes. And before lunch, someone was asking me, where are all the good stories about when CFEngine made lots of mistakes and destroyed lots of machines and stuff like that. And, well, you know, of course CFEngine has never purposefully destroyed anybody's machines, but stupid people using CFEngine have occasionally destroyed machines by accident. If you have powerful tools, you can make powerful mistakes. And yes, there was the time at the university when certain people had exported all of their NFS file systems publicly open to everyone, and CFEngine went happily through all of the file systems that were mounted on this system, cross-mounted, including root partitions, changing the permissions of every file on the system, rendering all of these workstations completely useless for about 10 workstations. But that wasn't CFEngine's fault. You know, you have to be really careful, and the one thing that I learned very early on from, actually Richard Stallman pointed this out, is that when you write software, you should always write safe defaults into the software, and you should make it hard to do dangerous things. You should make it hard to do dangerous things. So there's some point at which making things too easy is not a good idea. And that is, I believe that is built into the philosophy of CFEngine. We can discuss that afterwards. So here's hashing. Hashing detect all change is user-defined body. It's blue, it's user-defined, and it has no parameters, so all of the details are contained in this. And it's saying it's going to do MD5 hashing, it's going to report changes about the content, and it's going to update its database automatically when new values are created. So it will scream loudly when changes occur to the system, and then it will quieten down and accept these changes as having been given. This kind of host-based security is quite popular with people. I think it has limited value unless you're in a very secure environment where things really don't change. Because most of the changes that happen to systems are actually authorized or even accepted. For example, package updates. A lot of people switch on automatic package updates from Red Hat or SUSE or whatever. And then these changes occur, and then when they occur, these tripwire kinds of functions detect those changes and scream loudly, and you get lots and lots of noise and complaints about things which are perfectly okay. So we need to think carefully about when we use these kinds of tests and checks. Had I been working in the military, which is completely locked down and no changes are ever made without somebody pre-authorizing them, then this would be the kind of thing that would be useful there. Checking file systems, again, checking the space on the disk. This is the body that was included from the standard library, I guess. No, this isn't in the standard library, but this is a definition that we could have used. Again, volume matches volume, my check matches my check. Mounting file systems, NFS, this is one from the standard library. Again, NFS matches NFS, mount matches mount. You see the pattern between these things, how they're defined. And we can define as many of these things as we like in order to make it convenient and readable. Software package installation, this is the one where you definitely don't want to define your own bodies in order to communicate with these package managers on different operating systems which are shell commands basically, and they have quite complex parameters and return information in complex ways. We have to pass the output of these things and send structured input back to them, and it requires an awful lot of pattern matching and regular expression magic to make that happen. And once you've sorted these things out, you just don't want to touch them ever again. So these are all in the standard library. All right. Those were the promises that I wanted to run through. So we've spoken a lot about the basic model of CFEngine, the ideas of configuration management, the strategy that we try to use to solve complex problems by breaking them down into small problems that can be managed and kept as promises, things that can be maintained, not only said once and not only implemented once, but maintained over time. Promises can be really kept over time. And I've shown you how something about the agent works and a little bit about the client-server communication model, which of course is important in any kind of distributed system. And to finish off, I'd like to explore this idea of patterns a little bit more and show you some examples of the way that patterns can be used to simplify rules in CFEngine. One example of that is to use regular expressions. So I constructed a small example here of how you can search, how you use search to locate information when you really don't have sufficient information about your environment. You need to search through it to find what it is you're looking for. So a pattern you can identify in order to bring some optimization. And here's a simple example. I remember right back at the beginning of when I wrote CFEngine, one of the big problems in the mid-90s was disks were small and disks were expensive. Now we have the opposite problem. But back then it was important to delete files regularly and tidy up things and compress data and just in general manage the size of data. Still useful to manage the size of data in certain cases, of course, but disk is cheap now. So here's an example in which we could look for files in a particular directory of a certain type and compress them. And in this example, I look for PDF files for want of a better file description, a file extension. Compressing PDF files is not really generally much use since they're already compressed, but let's just do it anyway, okay? I can't think of another example. So in this directory, mark, temp, test, copy, imagine that there's a bunch of files, some of which are PDF files. And then we can try to select files from this list. So we're going to search. We're going to do a depth search, recursively search through these directories looking for files. And we're going to use file select, which is like, think of SQL select. It's a filter to filter out files with certain properties. In this case, we're going to look for files matching one of two patterns, either something.pdf or something.fdf, which are both PDF files. And if we find such things, then we're going to apply this transformer to the file, which is just gzip. So we're going to compress these files as such. When we have searches of this type, notice that CFEngine actually has certain variables that it will set. This scalar variable, this promiser, points actually to the current file that is being examined as CFEngine searches through this directory and all of its subdirectories. Of course, normally the promiser would just be this directory here, home mark test copy. But since we're searching, it's actually being extended by the search. If we want to know the exact file in that search that is currently being referenced, then CFEngine keeps account of that in a variable called this promiser. So we can use that to construct a rule, in this case, to compress files that get discovered by the criterion here. And the leaf name here of a file uses a regular expression to match the name of the file here, and then we can deal with that. So we can construct a search for a pattern and use that pattern to simplify the configuration, in this case the compression of a certain class of files on the system. So that's one example of this file. If you'd like to try it, this is another way of writing the same promise. We could have simply included the pattern in the promiser itself, as long as we're only going through one subdirectory. So if you want to try that example, this is also in the examples in the source code. It's called unit locate files and compress. I recommend giving it a try and playing around with the settings and picking some other files to compress, for example, and see how it works. One thing that regular expressions do very nicely is they not only match information, but they also allow you to extract parts of that information when you're searching. Really, when you're trying to manage a lot of information, you need some kind of search engine, some kind of discovery engine. We've seen that on the net with the proliferation of Googles and Bings and so on. But even when we're searching throughout a file system, on the Mac you have the Finder, and on Windows you have this corresponding find location search function. You always need to be able to search for things. What makes search really powerful is to be able to extract information from the search results using a model. And this is what regular expressions allow us to do, using so-called back references. Back reference allows us to extract parts of the string that have been matched. So let's suppose here we're going to try to create a files promise which says we will search through all of the directories home /.star matching anyone, .ssh authorized keys. So we're going to look through all of the authorized key files for users for Secure Shell. And then what we'd like to do is to add those users to another file by appending them in some way. And on the second line, you see home / parentheses around .star key file, create true, and then append if no such line to a key file using this variable $match.1. Now, let me first explain what this is going to do. So the second promise is going to look through all of the home directories, and of course it'll be home Mark, home Fred, home John, home Sarah, lots of names. So everything with the parenthesis .star is going to be a username. And then key file will be the name of some key file, and we're going to create this thing, and we're going to add to it a key, which is formed by matching this name. So key underscore username is what we're going to do. And the reason this works is that when you match a regular expression and you include parentheses like this around part of the regular expression, that forms a block or a reference within the regular expression whose value will be extracted in a set of variables called the back references. In Perl, I think these things are called $1, \1, \2, or is it $1, $2, I forget. In every regular expression enabled language, these things are available in some form as a numbered set. And the references go from 0 to the maximum number of parentheses that you have. So, and these get put into variables called $match.something in CFEngine. $match.0 matches the entire string that's matched by the regular expression. So that would be the entire file name. $match.1 is the first parenthesis. So that would actually extract the value of the username from during this search. So CFEngine iterates over all of the things that will match this search. It searches through home and all of its subdirectories, and whenever it's in home mark, $match.1 is set to mark. Whenever it's in home Sarah, the $match.1 is set to Sarah. And this allows us to extract, even as we search at random throughout file systems, information which can be used then to add, in this case, to a file. So the name of the user, we need to put it into a key file associated with that user, so we can extract that and cover all of these cases for all users using a single expression. That is the power of a pattern, the ability to extract and then use that information based on a simple model. One model to cover the whole thing. It doesn't matter if we have 10, 20, 100 users, this would work for all of them with a single rule. That's scalability. Here's another example of how you can use back references to change comments in files. It's quite often that we need to uncomment things or comment lines in files, in configuration files. This is a slightly silly example where we take an initially hash sort of shell type comment and turn it into a C type comment. Actually, if you're doing CSS programming, this might be, or JavaScript type programming, this might be something for you. So what this is doing is it's now, noted this is now an edit line promise. This is about editing files, which we haven't really talked very much about, but this is another thing that CFEngine can do. And this becomes something like a subroutine of a files promise. But what this is going to do is try to replace patterns within a file by first looking for this pattern hash parenthesis dot star parenthesis, and it's going to replace it with C comment, where C comment is a user-defined word, and here it is defined as a body like this. And select region, I'll show you in a moment, something else. But so what it's saying is we're looking for a pattern of anything starting with a hash that goes on to the end of the rest of the line, dot star. And around dot star, I'm putting a parenthesis, which doesn't affect the search, but it does tell me that I can extract this data as a variable afterwards. And that result will be available in $match1, because 1 is the first parenthesis. So you see what happens. It looks for comments, something beginning with a hash, to the rest of the line, and it takes everything except the hash and sticks it in $match1. And now I can replace that with a replace value, which is slash star star slash with $match in the middle. Then I've converted my Perl C shell comment, my Perl shell whatever comment, into a C comment. So I can do simple rewriting using the data that I've already discovered in the context where it was discovered. Very powerful technique for rewriting data. Now there's one other thing about this example which is useful in CFEngine 3, and I've got to tell you, because while we're talking about edit files, that one of the things that I'm still stupidly happy with about CFEngine 3 is the file editing promises that we made. In CFEngine 2, if anyone has used that, you'll find that there were 98 different commands for editing files. Don't ask me how that happened. When we rewrote CFEngine 3, We reduced those 98 down to 4 with parameters and settings. And it's that kind of simplification that's always a joy to, because it's knowledge management, right? That kind of simplification is always a joy, and it's the same kind of simplification we're trying to get into the configuration itself, of course. So anyway, so file editing is a very useful thing, and we are now able to search and replace for patterns. We can extract information from patterns and use it to rewrite data. Very nice. Another thing which is nice to do is to be able to select a region within a file to edit. So we don't have to edit a whole file, but we can pick a small part of a file to edit and just localize the changes around that. Here's an example of like a Windows ini file or Samba file, configuration file, which has the form of this text in the yellow box. It has sections with square brackets around them. These square brackets label the name of the section, and then the next one labels the name of the next section. And CFEngine will allow you now to define these sections using regular expressions which match those section lines. We could do the same thing for an XML file or an HTML file to a certain degree, as long as it's nicely written. But we simply search for something matching a named item. So this body select region my section takes one argument, which is the name of the section. Let's say the name is next section. My section, next section. So select start would be / square bracket, next section, square bracket, and /s star at the end, just to clean up any white space which might be lingering around. And then the end says match any other section-like line, whatever it contains, or the end of the file. So this will allow CFEngine to place limiters, delimiters between the first line and the last line that it's allowed to edit. And then within those bounds, you can do any kind of searching, replacing, inserting, deleting that you like, and it will be localized to this region. So when you have a structured file, something like this configuration file, it's a very useful thing to be able to do. And of course, most files today are files of this type, whether they are this kind or XML files or files with braces in them. We can usually come up with some kind of rule to be able to edit files according to this pattern. So again, another example where patterns turn out to be sort of advantageous. And here's an example doing the same thing using HTML or XML kind of regions. XML is difficult, of course, because if you know about the theory of languages in computer science, you'll know that XML is a context-free language. It has parentheses, basically, parenthetical levels, which cannot be understood with just regular expressions. Regular expressions don't know anything about parentheses. That means unless you have a well-behaved file and all of these things are on separate lines, you can't generically edit an XML file using search and replace pattern matching like this. Just can't be done. But in a lot of cases, you can approximate it to a good degree. If the file is reasonably tidily written like this, then each thing is on a line by its own, and you really can, because things have begin and end sections, and these things can be identified so long as they have reasonably predictable names. So we can often get around these limitations, which are fundamental, using approximations. And approximation, I think, is actually one of the key approaches to managing large systems, being satisfied with good enough in order to get the job done. Here are a couple of examples to try out those things if you want to play with these things at home when you get back. So, patterns. Well, where is CFEngine going? Started CFEngine in 1993. Really nobody knew anything about configuration management back then. It took 10 years to really research the problem and find what the challenges were and be able to solve them. Today, I think we know basically how to do configuration management, but the real challenge going forward is knowledge management. It's understanding the problem, grasping the scope, scale, and complexity of systems, and being able to do something about it, keep it under control, and manage it. And CFEngine is still, I would say, blazing this trail, still ahead as far as research is concerned in this area. And we have a roadmap for developing CFEngine in the future, which is quite ambitious. I just want to, in these last few moments, I want to share with you a few of the things going on today at CFEngine. Our roadmap is, of course, that we will always have the open source version, the community version, but we'll have these commercial extensions which bring specific functionality to bear that businesses are interested in. Nova first was 2 years ago. Constellation will be appearing this year. In Nova, it's all about managing a simple star network, central point, central management with satellites around the outside, simple model, very easy to set up. Constellation is about taking many of these star networks and joining them together, allowing them to cooperate and interact, getting the overview of the whole thing, while at the same time being a completely federated model. And then Galaxy is, far, far away in the future. We don't know what that is yet. Each of these has been designed to scale. It's been designed to integrate knowledge into the framework from the beginning, so that you really, from the very beginning, treat knowledge as part of the problem, not as an afterthought. Like security and any other kind of process, it has to be part of the process and not just a sort of an add-on. And business integration, people are screaming out today IT people as well are screaming out to be able to support businesses better, because the environment we live in today is much more commercial. IT has become commercial. It's no longer a research topic. The internet is commerce. And that's how these things grow and, of course, become mainstream. So to be able to handle mainstream needs and desires, we need to integrate with businesses. That includes being able to set policy and manage compliance. So CFEngine covers somehow the entire server lifecycle: build, deploy, manage, audit. This traditional lifecycle of machines. First we build the machine, we deploy software. You then have to manage things, respond to tickets. Of course, you don't have tickets with CFEngine. Things simply get fixed because they're part of your policy. And then audit, the ability to look into your system and see something about it, to understand what's going on, part of the knowledge, being able to prove to an auditor that your system has been compliant with regulations. This is an important point. And then another thing which is actively being pursued in a lot of areas is ITIL, service management, because service orientation is really a good model for applications and the internet. CFEngine also is to some extent service oriented in the way that it's constructed. So it fits quite nicely in with the idea of service management. And you may like to hate ITIL for whatever reason. It has some ideas, some of them are good, some of them aren't. It tries to make an attempt to formalize the idea of best practice in relation to service management. It doesn't always do it very intelligently, but it's based, of course, on human management, not about automation. So it doesn't know very much about automation. But still, I think it's important to take the good ideas from ITIL, use them to the best of their, use them for what they're worth, and discard the ones that are no longer relevant in 2011. And that includes not only making changes and having things like continuous improvement, quality assurance, making economic judgments about the value of changes and decisions, tracking changes. These things are about knowledge as much as they're about change. And I believe that this overlap between configuration and knowledge is really the key to taking the best of this world from ITIL, if you like, or service management, and turning it into a configuration strategy that can be automated. This diagram, which I borrowed from the internet again, shows you some of the areas of service management that ITIL discusses, and then I decorated it with little CF agents and CF knowledge agents around the outside so that you can see roughly how CFEngine covers these different areas, at least partially. This is another diagram from ITIL showing different aspects of service management, and the orange parts show the areas that CFEngine overlaps with. So again, you see there are things that CFEngine doesn't address in IT management. This is normal. But there are many things where CFEngine can play a role, and where particularly the ability to exert change control over change verification, to have knowledge of those changes you've made, to be able to prove the state of your system at any given moment. That's of enormous value to businesses today. How does Nova work, or these commercial versions work? Of course, you try to create a business model to support an open source project. This is a non-trivial task. We try to find a way to make a more valuable version, something that businesses would like to save money on, by making it easier, by adding certain features that are particularly of interest to businesses, especially reporting. Again, the ability to peer into your system and show that you are compliant with a certain set of regulations, to be able to show how well you're utilizing your resources, your data, your machine resources, the ability to reorganize, to virtualize, to tie in together with other information sources. Again, manage complex business problems. These are all things that people seem to have been willing to pay for in CFEngine. Integration, of course, with other software, little things that make life easier for business, so they don't have to waste development time of their own trying to reinvent wheels. So some of the things we've added in Nova for your interest are, first of all, an editor, syntax highlighting editor with command completion. What do you call it? An Eclipse-like editor environment, if you like, for developing policy, tied into Subversion and version control systems. We have knowledge management, which is this semantic web, where CFEngine will automatically scan your configuration and look at your system and build a semantic web based on this, showing the interrelationships between different parts of your configuration, ties this into the documentation about CFEngine, and of course ties it into a number of generic topics about the problem of IT management. So you end up with both a visual and a sort of an encyclopedic map that links all of the bits of data together and allows you to explore your way around this map and learn something actually about your system that you didn't know before you started looking at this thing. Systems are so big, you can't possibly know everything about your system. But by clicking around and exploring these maps, you can actually learn things that you didn't realize at all. There is, of course, the monitor daemon, which we haven't spoken about today. The monitor daemon runs in the background, collecting data. In the commercial versions, it's extensible, so we can add probes and so on. And to some extent, it can replace some monitoring software in a limited sense. If you take something like Nagios, for instance, which is a very popular monitoring system, CFEngine doesn't try to replace Nagios. It has rather different goals. Nagios is quite flexible, extensible. It gives you the ability to add probes yourself and creates quite detailed information about systems. CFEngine, on the other hand, tries to create a manageable overview, a summary of what is going on at a much less detailed scale. And the main design goal of CFEngine is to scale. It should be able to support tens of thousands of machines, which no monitoring system can do otherwise, without reducing the amount of information. Now, I think typical systems like Nagios, they get up to a couple of thousand of machines, and then you need to add more servers. You need to scale up the whole thing by brute force. At CFEngine, we want to be able to get an instant insight into the way a system is working at a level which is appropriate for configuration management, at a level that's appropriate for managing the resources of the system, not following a wiggly line because you're looking for some specific thing to happen, but to see the trends, to see the patterns of usage, and to be able to use those patterns again as knowledge that feeds back into the strategy for managing the system. And this kind of analysis is something else that we add in the commercial products. And to some extent, because CFEngine has its fingers into practically every detail of every system, it's easy for it to extract information and come up with something like a CMDB-like database of information about the machines, and inventory and analysis of the system. I don't like to call it CMDB because that has a lot of negative connotations, so I call it CFDB, just so that you can't possibly mistake it for anything bad. So, finally, how do you, after thinking about CFEngine, view CFEngine? It's a framework. It does a lot of different things. It touches on all kinds of different areas. It touches on security, monitoring, compliance, provisioning, building, deploying, automating, scripting, and it has these CFDB aspects, these database inventory aspects that relate to service management. It could be used for all of these things. Some people choose CFEngine just as a security tool. Some people use it just as a build tool. In an integrated management framework, I believe that all of this, the entire server lifecycle, should be part of a single seamless management framework. I don't believe in separating these things from one another. And as we get into this regime of disposable computing in the cloud, I think we're going to see this more and more, that the absolute necessity of being able to build, manage, and destroy machines on a almost random basis, on demand. This is the way the future of the world is going. And it also has to be a system that can scale from the smallest handheld devices, the mobile phones, to the largest supercomputers in banks and in financial institutions, or even supercomputers like at SARA, which do number crunching. That kind of scalability is important because the real cloud is not this myth of virtual machines in some cellar at Amazon Computing. It is all of the devices that all of you are carrying, from your mobile phones to your televisions to your computers, laptops, desktops, everything that's embedded into your jackets or watches or whatever things are embedded. It's going to be every surface that we touch in the next few years. It's going to be everywhere where computing exists. That is the cloud. The question is how we choose to manage it. And CFEngine is one approach to try to solve this problem, which we've spent a lot of time working on. This is the generic approach, the generic model, a promise. Make everything a promise, then it can be kept, it can be verified, it can be repaired, it can be analyzed, it can be judged. It represents a service. And that's all I wanted to share with you today. So thank you very much for coming and putting up with my failing throat. And I hope you enjoyed the session today. Thanks. If anyone has any questions, I'd be happy to ask them, or you can just come and ask me afterwards. Please feel free. Let's do it afterwards.